On with Unit 5, and in this video we're going to talk about Learning Target 6E Part 2, which is all about composition of functions. So by the end of this lesson we will be able to compose two or more functions together and find that composition of functions. So composition of functions is a new operation that we're going to be talking about where we use one function as the input to another function. So the formal definition says that the composition of a function f with a function g is this f of g of x. So this open circle here is purposely an open circle. If it was a closed circle, we would assume that we were talking about multiplication, but we have an open circle here to mean that we are composing these two functions together. Now, that in and of itself needs to be expanded out with a definition. So if we have this f of g of x, that is the same thing as f, and then instead of using this open circle, we can use parentheses to distinguish that we are taking f of g of x, where g of x is now the input to our original outside function f. And the way we pronounce that is f of g of x. Now, there's no multiplication going on here whatsoever. We are composing these two functions together, which ultimately means that we're using another function as the input to a different function here. So in this case with f of g of x is becoming the input to our outside function f of x. Now we're going to talk about the inside and the outside function a lot in this section as we go through a bunch of different examples to practice composition. Now, some of these are going to be computational examples where our input, instead of it being x, is going to be a number. So we're going to get a numerical answer out. And then we're going to slowly build up to examples where our input is actually going to stay as a variable x, or maybe we could change it into another variable, and we would get a different function as our final answer out. No matter what type of input we have, if we're inputting a number in for x or if we're leaving x as a variable, we always have composition working from the inside out. So I've got some color coding going on down below to help us see this. So by definition, f of g of x is f with these parentheses around our new input of g of x. And the way this works is we want to first evaluate what g of x is, and then use g of x as an input into our function f. And an important thing to notice here is that function composition is not commutative. So the way in which we compose two functions absolutely matters. Now there are some special cases where function composition is commutative, and that's going to be something that we do talk about in our next section, but for the majority of any two functions that we compose together, the way in which we compose them makes a difference in what our final answer will be. And so unlike multiplication, for instance, where 2 times 3 is the same thing as 3 times 2, meaning that we do have a commutative property there, that is not true with composition. So our first statement here, this is our f of g of x on the left side. That would not be equal to g of f of x for the majority of functions f and g. Hi, let's look at some examples. So for all of these examples we're going to do in this video today, we're going to use three functions. F of x is going to be defined to be x squared plus 7, g of x is going to equal 3x minus 1, and h of x is going to equal x squared minus 5x plus 2, and we're going to simplify the following as much as possible. So in our first example here, we have g of f of 3, and it's really important to make sure that we're able to say out loud what that question is asking us. We have no words in this statement at all, but I have to read the notation and understand what this means. So again, that open circle is meaning that we're composing the two functions together, and the way we would pronounce that is to say g of f of 3, with 3 being our input for our x variable. So let's expand out what this definition means, using kind of the parentheses instead of the open compose operation symbol instead. So g here being our first function is going to be our outside function. That will be of our inside function here is going to be f, and then of our input variable here is going to be 3. I'm going to use a lot of color coding in this video to help us kind of see the different layers here, because we have our innermost input of 3 being first substituted into f of x, And then once we simplify that down, whatever this f of 3 will be equal to, we will substitute into g of x. So for all of these, we want to work from the inside out. So let's start with the innermost portion here, figuring out what f of 3 means. Well, we've done questions like this before when we did function notation for the first time last semester. And if I wanted to evaluate what f of 3 is, we would use the function f of x here. And anywhere that we have an x, we are going to input 3 in place of that x. So for this example then, that would mean that we would end up with 3 squared, since we have x squared. So we're going to take that number, that input, and square it, and then add 7 to it. Just to keep up with the color coding, that input of 3 is getting inputted in for x. We are then squaring it and then adding 7. That's our entire f of 3 function. We will need to simplify that down, but that is still all inside this g function. So we have g of 3 squared plus 7, which we can definitely simplify down, and that will end up leaving us with g of 16, because we'll end up with 9 plus that 7 as we simplify stuff down. From here, now that we've simplified what f of 3 is equal to, and we ended up getting 16, our last step is to figure out what g of 16 is. So using the function g of x, anywhere we have an x in g of x, we want to replace that with a 16 for this example. And so what that would leave us with then is going to be 3 times the 16 minus 1. From here, we can continue to simplify this down. 3 times 16 minus 1 would give us 47 as our final answer then. So in this first example of composition, we can see that what's really happening here is a layering process of 2 different function notation problems in one. We're starting with the innermost function and simplifying down what f of 3 is equal to. Once we simplified down that f of 3 was equal to 16, we are then finding what g of 16 is, and then simplifying that down to get our final answer. Composition is a huge concept that is used later on in all of the math classes that you guys are going to take past this, and it's something that in my AP Calculus classes when I teach it, we look at a composition in some type of format pretty much every day in class. It gets hidden into a lot of problems, and this concept and this ability to compose 2 functions together allows us to open up a lot more doors of different kind of concepts in mathematics that we can talk about. So in here, we're starting to build in those first couple layers together. Let's look at our next example. How would we pronounce this question that we were being asked in problem 2? Think about how you would say this with this f, open circle, g, and then these parentheses of 3. So the way we would pronounce this would be f of g of 3. So we always start with that outside function. So f first of the next function g of 3. We want to transform that and write this with more of the parenthesis type of notation. It's a lot more helpful to see that. Why don't you guys pause the video here and expand out what this would mean using the parenthesis definition. So to expand this guy out, we would end up with f of g as our next function, and then we still have 3 as our input. The reason that we're using 3 as our input on both examples 1 and 2 is we're going to see that we do not end up with the same answer here since we are composing f and g in 2 different orders here. And so I wanted to see that with a hands-on example. Our next step from here is to work from the inside out. So I want to first figure out what is g of 3 going to be equal to, and then that will get subbed into our f function. So I still have f of all of this. To figure out what g of 3 is, we use the function g of x, and we substitute in 3 every place we have an x. So we're going to get 3 times that 3 input minus 1. Since our g of x function was 3x minus 1, we'll end up with 3 times 3 minus 1. Simplifying that down, that will end up leaving us with f of 8, because we'll get 9 minus 1 and end up giving us 8. From here, we can figure out what f of 8 is by using the function f of x, and anywhere that there is an x, we are subbing an 8 in place of that x. So we will end up with 8 squared plus 7, which we can continue to simplify that down. 8 squared is going to give us 64, and then 64 plus 7 will give us 71 as our final answer. So in these two first examples, I think it's great to compare them side by side and see that although we're using both f and g in both of these examples and we're using the same input of 3, we ended up with two different answers here because the order in which we composed the functions together was different. So in example 1, we had g of f of 3 versus in example 2, we had f of g of 3. And so this is one example of where function composition is not a commutative property. So the order in which we compose them absolutely matters. Okay, let's look at some more examples. In example 3 here, I want you guys to pause the video and say out loud to yourself how you would pronounce what this question is asking you. So in problem 3 here, we're composing f with h, and our input's going to be 1. The way we would say this is this would be f of h of 1. To expand this out using the parenthesis kind of definition, that would leave us with f of, our next input is going to be h, and then our variable for x is, or our number in place of x is going to be 1 then. Now to start solving this, how are we going to work? Are we going to start with the function f, or are we going to start with the function h? So for all of these composition problems, we're starting from the inside out, which means I need to start with what h of 1 is and figure out what that is first. So the f is still going to be here. We're going to have f of something, and that something is going to be whatever h of 1 is equal to. Well, h of x, we haven't used it yet, but h of x is equal to x squared minus 5x plus 2. In this case, there's multiple places where we have an x here. We have the x squared and the minus 5 times x in this h of x equation. What that means is that when we go to substitute in 1 into h of x, we're going to have to substitute a 1 into both the x squared place and the 5 times x. So what we'll end up getting is we're going to end up with 1 squared minus 5 times 1 and then plus 2. And I did not leave myself enough space there. All of that is again still inside this function f. And our input into each of these is going to be 1 squared, since we're finding h of 1, minus 5 times 1 plus 2. Our goal from here is to simplify down 1 squared minus 5 times 1 plus 2. So we'll end up with 1 minus 5 plus 2 will leave us with negative 2 then. Our last step from here is to figure out what f of negative 2 would be. To find f of negative 2, we're subbing in negative 2 into any place that there's an x in the function f of x. F of x is the x squared plus 7, so we're going to end up with negative 2 squared plus 7, which we can then simplify down. Now negative 2 squared is going to give us a positive 4, because we're squaring both the negative and the 2, and then we'll end up with 4 plus 7. We'll get a final answer of 11. One thing I do want to point out here is because our input is negative, we do have to make sure that we have the parentheses around this negative 2 squared, since we need to square both the 2 and the negative. So a common mistake in math is to kind of get a little lazy with our notation, and I want to remind you guys that negative 2 squared without parentheses is not equal to negative 2 squared with parentheses. And so even if we're saying in our head, oh yeah, I'm going to square it, I have to make sure that I'm writing it down correctly, because all of our work is being checked there as well, and we want to make sure that we have a logical step as we move through a problem from point A to point B. Let's look at some more examples. So we're still using the same functions, I just have them reprinted at the top of the page for convenience. In example 4 here, it has something that looks a little bit different. How do you guys think that you would pronounce that question in example 4? So in example 4, we have the function g composed with itself again, which is actually something we can do. We don't have to use two different functions. We can use another function inside of itself again. So the way we would say this out loud is this would be g of 5. If we're going to expand that out with this parenthesis notation, instead of using the compose symbol, we would have g of 5 as our innermost input there. Now from here, we're going to work from the inside out just like we've done in any problem. So why don't you guys pause the video here and figure out what g of 5 is equal to, and then we'll check that step together. So to get g of 5, we're substituting 5 into g of x here. So g of x is that equation 3x minus 1. So we are going to end up with 3 times 5 minus 1 then. Now as we go to simplify that down, 3 times 5 is giving us 15. 15 minus 1 is going to give us 14. So g of 5 was the innermost function. We were able to simplify that down to be 14. Our last step from here is to figure out what g of 14 is now equal to. Now g of x, we're still using that same function of 3 times our input minus 1. So we'll end up with 3 times 14 minus 1, which when we simplify that down will give us positive 41 as our final answer. So we've seen in our examples so far that we have a lot of variety that we can do with these. Even though I only have 3 different functions that we're working with, we can get really creative with how we compose these together because we do have the ability to use the same function multiple times. Something else we also have the ability to do is to do this more than once. So in our first 4 examples, we only took 2 functions and we composed them together. Well, this concept can be expanded out to compose an infinite amount of functions together. So let's take this one step up and compose 3 different functions together. In this case, we're going to work from the same. We ultimately are taking the first function of the next function of that now innermost function. So in example 5 here, the way we would pronounce this is this would be g of h of f of 0. So we've got a lot going on. It's much easier to look at it with the parenthesis notation, so let's expand that out. G is now our outermost function. Since that's the first one that comes, our next function is going to be h, so we're getting g of h of our next function from there is going to be f, and then our input this time is going to be 0 for our x value. So we ended up with g of h next, and then of f of 0. Now I know that that looks super cumbersome, but we want to work on this problem the same way we've done all of them. We are starting from the inside out. What is our innermost function in this case? So in this case, our innermost function is f. So the first thing we want to figure out is, well, what is f of 0? So I'm going to just go ahead and rewrite the g of h and have that already kind of ready to go. And why don't you guys pause the video here and figure out what f of 0 is going to be equal to, and then we'll check that step together. So to find f of 0, we're substituting in 0 every place that there is an x in the f of x equation. So in this case, what that would leave us with is 0 squared plus 7, which we can then simplify down. 0 squared is just going to leave us with 0, and then 0 plus 7 will give us 7 overall. So once we simplify this down, we're getting g of h of 7 then in this case. So that was dealing with our innermost function of f of 0. Now from here, we can continue to work from the inside out. So our next step is to find what h of 7 is equal to. The g is still going to be there. Why don't you guys pause the video right here and identify and simplify down what h of 7 is going to be equal to. So to find h of 7, h of x is this x squared minus 5x plus 2 equation. So we do have to make sure that we're substituting in 7 into every single place that there's an x. So we're going to get our input squared minus 5 times our input plus 2. In this case, our input is that 7, so we'll get 7 squared minus 5 times 7 plus 2, which of course we can simplify down. 7 squared is going to leave us with 49, then 5 times 7 is 35. 45 minus 35 plus 2 will leave us with 16. Now our last step from here is to solve what g of 16 is equal to. Why don't you guys pause the video and simplify down what g of 16 is going to be equal to. So g of x was that equation of 3 times our input minus 1. Since we're finding g of 16, we're going to get 3 times 16 minus 1, which will leave us with 47 overall as our final answer. So we've seen already in our first 5 examples that we can layer quite a bit into here. In all of these examples, they all had something in common where our input was a number in this case. And what that allowed us to do is if I'm inputting a number, I can simplify down each step quite a bit, and I'm going to end up with a number as my final answer overall. Now that's not the only way we can compose functions. We can actually leave our input as an arbitrary variable x, and we're going to look at some of these examples. So in this case, we do have the ability to simplify down and maybe FOIL or distribute and combine like terms. For the sake of this video, I just want us to practice inputting in and finding how to do the composition and not focus too much on the simplification. So let's look at this first example here. How would you guys pronounce what's being asked in problem 6? So in question 6, this is f of g of x. So if we expand this out using our parentheses, we're getting f of, our next input from there is g of x in this case. Just like we did when we had numbers instead of the x there, we're still going to work from the inside out. Well, what is g of x equal to? G of x is equal to this 3x minus 1. So I'm going to input the entire definition of what g of x is in place of where the g of x is written in our equation. So instead of f of g of x, I can replace g of x with 3x minus 1, since that's what it's equal to, and that's still going to be inside this f function. From here, we're going to continue on the same way we did up before. The difference now is I can't simplify 3x minus 1. There's no like terms here for me to combine, but what I can do is use 3x minus 1 as my input into the f of x equation. So f of x itself is this function x squared plus 1. The difference now is instead of me inputting an x or inputting another number, I am actually inputting 3x minus 1 in place of this variable x. So we're still holding on to the same format. So my f of x is still something squared plus 7. So that structure of the equation f of x is not changing, but instead of it being x squared, I'm replacing all of the x's with 3x minus 1. From here, we could multiply, distribute, combine like terms, and simplify down, but we just want to focus on how we input these together right now, so we're going to leave all of our answers unsimplified when we have variables instead of numerical numbers being inputted. Let's look at another example where our input is an x. So in example 7 here, we have g of h of x. Why don't you guys pause the video here and write this out using the expanded definition with the parentheses. So to expand this out, we would end up with g of our h of x. Just by expanding that out instead of using the compose symbol, and we can use the parentheses instead. Just like before, we want to start from the inside out. So which function is our inside function? Is it g or is it h? So our inside function here is h of x, and we can replace what h of x is equal to using the equation that we were given up above. Scroll back up just so that we can double check it, but our h of x is this x squared minus 5x plus 2. So I can input that in here. We'll still have, I'm going to fit it down below, we'll still have g of, but instead of g of h of x, since h of x is equal to x squared minus 5x plus 2, we can input that into our g of x function. Now our next step from here is to figure out what this g of x squared minus 5x plus 2. So g of x, I'm going to write it over here on the side, was defined up above to be 3 times x minus 1. Well, this x is just a placeholder. I could call it g of purple blob. That would be equal to 3 times purple blob minus 1. Now last semester when we first introduced function notation, I kind of slid a composition problem in there without you guys knowing it during class when we did something where we did g of smiley face. This is that same concept here. Instead of it being smiley face or instead of it being an x, we are just using an entirely different function to input into another one. So when we did something like g of smiley face last semester, well, we said that that would be 3 times smiley face minus 1. Well, here, in this case, our smiley face is this x squared minus 5x plus 2, since that's what h of x was equal to. So we can do the same thing here. We're going to get 3 times whatever our input is minus 1. But in this example 7, our input is going to be that x squared minus 5x plus 2. And that will be our final answer on problem 7. Now technically we could distribute the 3 and combine like terms, but again, just for the sake of, as we're learning it for these first couple times, we just want to focus on inputting the functions into each other and composing them instead of simplifying everything. All right, we've got a couple more examples to look at. So let's look at example 8 here. We're still using the same functions, f, g, and h as before. What is example 8 asking us to do? How would we say that question out loud? So in example 8, we're asked to find h of f of x. So to expand this out using the parentheses notation, this would be h of our f of x. From here, why don't you guys pause the video and solve this one out on your own. So figure out what f of x is equal to, and then sub that into our function h of x, and leave your answer unsimplified. So to check that, our f of x is equal to the x squared plus 7. So that's going to become our input to h of x just by replacing f of x with what it's equal to. H of x we know is this equation of x squared minus 5x plus 2. Again, this x is just a placeholder, so it's representing whatever our input is. In this case, our input is the x squared plus 7. So we're going to end up with that input squared minus 5 times our input plus 2. So this is the structure of h of x. That structure is not changing. But instead of it being x squared minus 5x plus 2, our new input now is going to be x squared plus 7 for both of those inputs. So that leaves us with a final answer then of x squared plus 7 squared minus 5 times x squared plus 7 plus 2. So I'll get a couple more examples. So in example 9, why don't you guys pause the video and solve this one out completely on your own, and then we'll check it together. So in example 9, if we were to say this question out loud, it's asking us to find h of g of x. So writing this out using the parenthesis notation, we have h of g of x. From here, we can start working from the inside out. So we're going to start by replacing what g of x is equal to. G of x is equal to 3x minus 1. So we'll replace that. From here, our next step is to find what h of 3x minus 1 is. Now, h as a function is again equal to my input squared minus 5 times my input plus 2. So that format of something squared minus 5 times something plus 2 is still staying because that's what the function h is defined to be. But instead of it being x squared minus 5x plus 2, our input now is the 3x minus 1. So we get to replace all of these inputs. Instead of having an x, we're going to replace it with a 3x minus 1. And that will be our final answer. Of course, we could FOIL stuff out, distribute, combine like terms, but for the sake of right now as we're introducing it, we just want practice composing the two functions together without worrying about simplifying. One thing I do want to point out is how similar the answers to 8 and 9 are. And the reason that is because we have the same outside function for both of these. In problem 8, we had h of f of x, and in problem 9, we have h of g of x. And because of that, although these inputs here are going to be different on each one, because we had f of x in problem 8 and g of x in problem 9, the structure itself of being something squared minus 5 times something plus 2 does stay intact because that's what this h of function is representing. So I could go back to using the smiley face concept. H of smiley face will always be whatever that input is, so smiley face squared minus 5 times smiley face plus 2. Question I always tend to get is, well, how much work do I have to show? I'm starting to see how I can kind of piece this all together and do this all out in my head. That's great, but for you to, in order to you to explain to me that you understand what's going on, I do need to see all of these steps worked out. And as stuff becomes more complicated over time, we just want to get in a good habit of writing out all of our work in an organized fashion so that we can see our thought process. And not only is it a thought process to make sure that you're understanding it, but you're also explaining it to anybody who is reading your work by organizing all of our work here. All right, let's look at one more example. So we're going to put all three of these together with an x as our input as kind of a challenging problem at the end to try. So in example 10 here, we have h of g of f of x. Why don't we first write this out using our parenthesis notation instead? So to check that parenthesis notation, we would have h of g of f of x as our innermost function there. We're going to start from the inside out, so I'm going to start by replacing what f of x is equal to. F of x is equal to x squared plus 7, so I can replace that f of x to be x squared plus 7. Again, I still have g of that, and then h of all of that mess, so all of that is still staying there. From here, our next step would be to find what g of x squared plus 7 is. Why don't you guys pause the video right here and solve out what g of x squared plus 7 is. So to check this, I still am going to have this h function. I'm going to just put big parentheses there. To find g of something, g of x is the 3 times our input minus 1. So what that means is we'll end up with 3 times our new input minus 1 then. And in this case, our input into g of x is going to be x squared plus 7. Now our last step from here is to find h of all of that mess. So again, h of x is that function where we have our input squared minus 5 times our input plus 2. So as we go to solve this out, we're going to get something squared minus 5 times something plus 2, where that something is this whole input that we have in our prior step. So we're going to get 3 times x squared plus 7 minus 1. That whole quantity is being squared. Minus 5 times this whole quantity of 3 times x squared plus 7 minus 1. And then, of course, we still have that plus 2 on the end. And that will be our final answer, for this last example here.